Good afternoon. My name is Stephen Richardville. This is Advanced Statistics Fall 2023, and we are doing assignment 5.1 today. If I go to my assignment, what we're going to be doing is performing a paired t-test on coaching instructional data for games 1 versus game 2. These bowlers are going to bowl a game, get 15 minutes of instruction, bowl game 2, and we want to use a paired t-test to see if there's a significant difference in their scores between game 2 and game 1 to see if the coaching maybe helped. And so our first goal is to go to the data, and we want to make sure that we meet the assumptions for the paired t-test. The first thing to do is look at the difference in the scores for game 2 and game 1. We actually need a third column here. We need to compute a new variable, and our new variable is going to be the difference between game 2, which I'm actually going to assume. Let's get rid of that. Do game 2 minus game 1. I'm actually going to assume that game 2 is going to score better than game 1, but it doesn't matter. We can do game 1 minus game 2, but we want to see the difference. We want that difference data because we want to see if that difference data has a normal histogram curve in order to have the assumptions met to perform the t-test, even though we're supposed to assume that the assumptions are met anyway. But if I go to descriptive statistics, frequency, and I'm going to look at the difference. And what I want is a chart. I want a histogram chart, not a pie chart, histogram chart with a normal curve. These two things clicked. There we go. Hit continue, and everything looks good. And let's see. There's my pretty good normal curve on my histogram chart. So all set. So we're ready to perform the t-test. We've made a new variable through transform. We've checked the histogram to make sure it has a normal curve. Our assumptions are met. Let's go actually perform the test. We don't need to save that. What we're going to do is go to analyze. We're going to come down and compare means and proportions. And this time we're going to the paired samples t-test. And we're going to look at game 1 as one variable and game 2 as a second variable. See if we need to do anything over here. Nope, we're all good. And let's compare. All right, so what do we have? We've got a mean for game 1 of 90 and a mean for game 2 of 94.95. So here's our means right up here. We have a correlation of 0.556, so that's a positive correlation. 0.556 is moving towards the strong side. I would say 0.8 is getting strong positive correlation, whereas negative 0.1 would be a strong weak correlation. Strong negative correlation. 0.556 is kind of edging towards strong, but definitely a positive correlation. And then when we go down here to paired samples t-test, our two-sided p is 0.108. So that significance of 0.108 is greater than 0.05. So it actually, we would accept the null hypothesis that there really is no difference between the means of game 1 and game 2. It seemed like the means 90 versus 95 almost. There might be a significant difference, but we really, for a significant difference, want a two-sided p-value of less than 0.05 for it to be significant. So 0.1 is greater than 0.05, which means there's really not a significant difference. The null hypothesis is accepted in this case. A little bit tricky on our videos for the course. There were two situations where we had a value of greater than 0.05. In one case, the null hypothesis was rejected, and one it was not. So that was a little bit tricky. But in this case, really, the null hypothesis should be accepted because my value is above 0.05. If we want it below 0.05, I'm going to reject the null hypothesis. There is a significant difference. In this case, it's above 0.05. Hope this helps. 5.1 is done. We'll see you guys next week.